Assalamu alaikum, Bismillahirrahmanirrahim. Welcome to our JNCIS-SP course. Today we discuss basically routing section. Routing section have two appendix. One appendix regarding IPv6 and another appendix will be ISIS, intermediate system to intermediate system. It's an IGP, interrogated protocol like SPF. So next class, I will discuss about ISS, but today we discuss about IPv6 Internet Protocol version 6. Okay, let's start. First, what is IPv6? It's another internet protocol, and the version is 6. The You can say this is also it's a next generation protocol, and that have many benefits, many features compared to IPv4. So the uh, IPv4 have not enough IP address space. That's why we have to move another protocol, and the protocol is IPv6. And the ITF already defined IPv6 parameter, and there have one RFC 2460 RFC. You can check this RFC for IPv6 details. And this is the comparison between IPv4 and IPv6. Okay, so in IPv4, if you compare regarding bit, IPv4 is 32 bit, but IPv6 is 1 to 8 bit. You can say IPv4 is 4 byte and IPv6 is 16 byte. If you say the address space, IPv4 support 4.2 million like this, but in IPv6 address space supports 2 power 1 to 8, and IPv4 support 2 power 32. Okay, so huge number of address have in IPv6, and we can say we can add IoT device and every networking capable device in the internet without net, no need net. In IPv4, for extension of IPv4, or if I just net is basically comes in IPv4 for extend or just enlarge the IPv4 life. That's it. But in IPv6, no need net. You can assign unique public IPv6 address to your network device directly. No issue. And IPv4 have two options for configuring end device. You can configure your end device through the DHCP, Dynamic Host Configuration Protocol, or you can configure your end device statically. In IPv6, you have both options. You have DHCP option. You can configure statically. Also, that have auto configuration feature. Okay. IPv4 support IPsec, and IPv6 also support IPsec, but in IPv6, IPsec is necessary, but in IPv4, IPsec is optional. You can add or not. So another option is IPv4 header that have some integrated options in IPv4 header, but in IPv6 that is fixed, and you can add extension header when you add additional options in IPv6. That means you can say IPv4 is variable length, but in IPv6 that is fixed length. So the benefits of IPv6. What is the benefit? So you can say, what is the benefit? Number one, more efficient routing. You can say more efficient routing. In you can you can have in IPv6. You can deploy quality of service here and no need net. So router resource will be less used. Okay. If I if I do net in our router, net process also take a local resource. Okay, CPU, RAM, but in IPv6 no need net. So your router have more resource for utilize another process. And network layer security and IPsec is built in IPv6. Edge of management using stateless address auto configuration. Auto configuration feature is available in IPv6. And first and very most important thing is improved header format and reduce the header overhead in IPv6. So in next couple of slides, we can see the difference between IPv4 header and IPv6 header. So say this one, IPv6 header structure. Okay, so total is 40 bytes. And see here, IPv6 header has the following improvements. Fixed length 40 bytes. IPv6 header is 40 bytes, and that's fixed length 40 bytes header. Simple and more efficient processing in happened in IPv6. Extension header handle additional options. Extension header means if you add some additional feature like IPsec or other things, then extension header will introduce in IPv6. And several IPv4 fields have been removed, and IPv6 header option is very simplistic. Okay, so see the options, how many field is available in IPv6. First option is version. This is IPv4 or v6. Second option is traffic class. You can compare it with the IPv4 type of service. Flow level is 20 bits. Payload length is 16 bits. Next header is 8 bits. Hop limit just for TTL. This can use 8 bits. Source address and destination address. So you know the IPv6 address is 128 bits. So source address take 128 bits and another destination address will take 128 bits. So that is the IPv6 header structure, and so the just see the comparison here, IPv4 and IPv6 packet header. Left portion is IPv4 packet header is here, and here is IPv6 packet header. And in IPv4 packet header, there is more field compared with IPv6. Okay, so firstly, see the coloring combination. See the blue color. This is blue. Fields are the same in IPv4 and IPv6. In IPv4, source address, destination address available. Source address, destination address also available in IPv6 header field. Okay. Any question? What for is it flow label? Flow label used for I flow level details in next section. I will share with you. And and the version information. This is IPv4 and this is IPv6. Okay. And green color fields removed in IPv6. Options, padding, header checksum, flags, fragment offset, identification, ISL 1, 2, 3, 4, 5, 6, 7. 7 field has removed in IPv6. And the gray color, name and position changed in IPv6. Gray color, this one is the gray color. So total length here is total length is you can say total length basically payload length you can say just naming change. Time of life that means hop limit. Protocol will be included in next header. Okay. And traffic class, basically traffic class is equal to type of service, basically type of service. Okay. And the green color, new field in IPv6, that is flow level. Flow level is completely new in IPv6 header version. And you are asking what is flow level and what is the function of flow level. Okay, I will discuss it. I will discuss about flow level. Routing, no flow level is here. Oh, sorry. There is no explanation about flow level. Okay, let's go flow level. Flow level in IPv6 header. A flow level in IPv6 header is a 20-bit field that allows a source to identify a specific stream of packet. Essentially, labeling a flow of data can be used routers to provide special handling of that flow, like prioritization certain packets, directing them along a specific path based on the flow level value. It is essential way to request a specific treatment for a particular set of packets from the source to the destination. So flow level and the basic function is the mark the packet to take decision to forward you can forward packets to a different path. You can prioritize those packets. All will be in flow level. That is flow level. You can say load balancing, you can say quality of service, you can say traffic engineering. Okay, so this function will be happened in flow level. Just mark your packet and take the action. You can set the quality of service. If voice traffic, you can set high priority this traffic. If the normal traffic, you can set load balancing in different path. You can traffic engineering in underutilized path. So for that use cases, we can use flow level. Clear? This is flow level. No. What is the function of flow level? Okay. So next one. IPv6 extension header. See here, one interesting thing. IPv6 extension header. So this is a 40 bytes is fixed length, but you can also add extension header in IPv6. Simple packet header provide faster processing. IPv6 deals with IP options using extension headers. IPv6 defines 6 extension header. That means in IPv6, and this extension header can be included or not included. Number one, hop by hop options. That means signifies that the options need to be examined by its node along the path of a packet. So if you want to check your packet in every router, so this option can be used for this option can be used in extension header as extension header. Another one is routing, provides a list of intermediate nodes that should be visited on the path to the packet's destination. Routing obviously will be present in your router if multiple router is connected with each other in your organization. Without routing, that will not make sense. Okay. Fragment. Signals when a packet has been fragmented by the source. You can fragment your packet or not fragment your packet. That will be added in extension header. You know also this basically depends on interface MTU. Destination options. In destination options, you can say options examined only by the destination node and capable of appearing twice in a packet. This is the basically destination options. Authentication. The packet will be authenticate or not authenticate. If you use authentication extension header will be added. Like example, you just making VPN in different site. You can say site to site VPN. So in site to site VPN, you use their IPsec. You use their IPsec. In that case, you can add authentication to authenticate your site, one site to another site, or one site with another site. Okay. Encrypted security payload, that is basically example of IPsec and encryption like this. So those are extension header you can add with 40 bytes fixed header in IPv6. And next section, we will discuss IPv6 address type. IPv6 address type. So there are multiple address type in IPv6. There is public unicast or global unicast address, private address, multicast address, link local address. Okay, multiple address type is available in IPv6. So first, just showing here some major uses of IPv6. So that is extending address space is major reason for IPv6. IPv6 have huge address space. This is the major region to go with IPv6. You know already IPv4 address exertion is predicted, and near future I think IPv6 will not used. I think all are will be in IPv6 and they are communicating with IPv6 to another IPv6, not IPv4 to IPv4. And IPv6 is 128-bit. I already discussed regarding this, and those have 2 power 128 address space in IPv6. You can say 2.95 address will be address exists for each person on Earth. That is used. Every points here just express these huge IPv6 address. There is a huge IP or address space in IPv6 basically. Number one, address types. So there is basically three types of address in IPv6. Number one is unicast, second one is multicast, and lastly anycast. So first one, unicast. Unicast means just you send one packet from one single source to another single destination. That is called the unicast. Okay. So in unicast, I have also available in IPv4, and second one is multicast. Multicast, and that is very interesting, and this communication is happened in a group, and multicast address is defined in IPv4. Multicast address is 224.0.0.0/4. That block is used for multicast in IPv4, but in IPv6, the multicast address will be a double F double zero double colon slash 8. That block will be used for multicast in IPv6. There is no concept. Yeah, there is no concept in basically there is no concept of broadcast in IPv6, but broadcast concept is available in IPv4. The new concept, Anycast concept is available in IPv4, IPv6. And what is the meaning of Anycast? The Anycast is you can assign single IP block in multiple router interfaces. You can say you have multiple data center in the world. You can consider Google. Google have multiple data center in the world, and their address space is used every location. Same address space is used in every location. Okay. So how is it possible? That is Anycast. Okay. I'm getting a response from nearest data center. It can be from if you consider from Bangladesh, it can be you are getting response from India or Singapore. Both are nearest one. Okay, so this is the concept of Anycast. Address notation. How to write IPv6 address. What is the rules and regulation to write IPv6 address? First one is you have to make total 128 bits, number one. And address will be expressed in hexadecimal format. Address will be expressed in hexadecimal format. So 8 16-bit hexadecimal blocks. That means there is 8 field. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 field. And every field have 16 bit. All are hexadecimal character. One character is 4 bit. So 4 character is available here. So 4 into 4, that is 16 bit. So 8 field, 16 bit hexadecimal block separated by colon. Separated by colon. And total will be 128 bits. And to make shortcut IPv6, we can use two rules. So one rule is you can omit leading zero. You can omit leading zero. That means this is leading zero, this is leading zero, this is leading zero, this is leading zero. So if you omit this one, so address will be this. Okay, and another rules is double colon can replace consecutive zeros or leading zeros or trailing zeros, but cannot be used twice in a address. That means if you have multiple zero in successive order, so you can replace it single double colon. That means you see 5 field here. So three field is here. Double colon here, three fields. Okay. This is the true shortcut to make IPv6 simple. And another one is prefix notation. Like IPv4, IPv6 address, first one is prefix and slash, then is prefix length. So first one, this one is the prefix, and this one is the prefix length. Prefix length. So if you say the network block here, so this is 64. That means these are host bit. This 64 is host bit. So if you say as a network, that will be slash 64. This one slash 64. Okay. So this is the way to write prefix. And some special address here, double colon slash 128. This is the and this address is basically unspecified. Double colon 1 slash 128. This is for loopback, IPv6 loopback. And double F double zero double colon 8. This is for multicast. And FE80 double colon slash 10. This is for link local. Link local. This tab basically address type, nothing else. We have to remember those address types. Address allocation. What is the rules of address allocation in IPv6? So say here subscriber, and this is the subscriber type. This column is the subscribers type. If subscriber is home network subscriber, so prefix will be 48-bit prefix. Small and large enterprise 48-bit prefix, very large subscribers 47-bit or multiple 48-bit prefixes. Mobile networks such as vehicles, mobile phones with an additional network interface, that will be 64-bit prefix which accept multiple connection through a single prefix. And a single PC with no additional need to subnet, dialing up from a hotel room, 128 bits is enough as part of 64-bit prefix. Thus, while getting IP from 64-bit prefix. So minimum is 64. This is the address allocation process. And here is special address. Only double colon means all are zero. Only double colon means all are zero. And loopback address is first 7 field is 0 and last one is 1. And that is expressed in double colon 1, that is localhost or loopback address. These two addresses are special address. And IPv6 default address is this one, double colon slash 0. This is the IPv6 default subnet, and this subnet have all IPv6 address here. Okay, like IPv4 0/0. And another section of address scope, unicast. Multicast address support scoping. Scope can be local or global. Multicast address supports 16 different types of scope, including node, link, site, organization, and global scope. 4-bit field in the prefix identifies. No need this one. Link local unicast address. That is very important because this address is used for link discovery, duplicate address detection, and for this address, we cancelled broadcast concept in IPv6 basically. So link local address is starting FE80 every time. Link local address will be start with FE80 double colon slash 64, and last 64 is coming from network interface card. Basically comes from interface card MAC address. And global unicast address. Global unicast address is basically the public address. If you compared with IPv4, this is basically a public address, and those address basically unique in every for every station. Okay, and the format is FP. FP means basically public topology. Public topology. There is a multiple segment here. So prefix prefix is present in first. Yes, FP means the binary prefix 001 is present in the first three bits, as this identifies the aggregate global unicast address space. Okay, so you can say 20000 double colon slash 3. This is the 3 bit. This one is 3 bit. And second option is global routing prefix, that is 48 bits. And third option is seed, that means up to this 45 plus 3 is 48. 48. And up to this is 64. Up to this is 64. For large service provider, will get normally slash 32. Normally we'll get slash 32. So subnetting is happened in this 48 bits, 45 bits when delivering IPv6 address space to customer. So global unicast address, that is 48 bits. See here, reserved for hierarchical address allocation, provide the highest level of address summarization typically applied at tier 1 ISP, regional address allocation entity, and large peering points. Those address is given from this global routing prefix portion. And third, 16-bit is used for local assignment. Just to consider this internet service provider getting IP address space is slash 32, and two companies connected with the internet service provider. One company is ABC, another company is XYZ. And first, you can deliver single slash 48 to ABC and another slash 48 to XYZ. If you think company ABC is more customer, have more customer compared with XYZ, you can deliver multiple 48 to company ABC. Okay. And last one is 64-bit combination. When ABC company deliver IPv6 address space to their customer, it can be home user or it can be a small enterprise network, small office, home office type. In that case, they deliver slash 64 towards the customer. Okay, so this is the address allocation or calculation. So interface ID here, that means last one, interface ID. In interface identifier or interface ID have 64 bits. Okay, 64 bits. If we configure auto configuration, or if I use EUI64 method, those method takes MAC address from network interface card. They take 48-bit MAC address, 48-bit MAC address, and they insert a 16-bit value inter between MAC address and make the total 64 bits. That method is called the EUI64. So see here, this is example MAC address. So this one is the first 24 bits, and this one is second 24 bits. Second 24 bits here, first 24 bits here, and inter between these triple FE is inserted. So total will be 48 plus 16. That will be total 64 bits. Okay, that is the way to make UA64 address in IPv6. IPv6 auto configuration. So in IPv4, static IP address assignment, you can assign IPv4 address in your end device statically, or you can use DHCP to dynamically deliver IP address from DHCP server to DHCP client. Okay, this is the process of address assignment in IPv4. So this is the way, and what is the way in IPv6? Stateless auto configuration, you can just enable the IPv6 feature in interface. Interface will automatically configure IPv6 address. This feature is called the auto configuration feature. So stateless auto configuration element. So what is the number of options or number of item is available or exist in auto configuration process. Number one is extended unique identifier. I already show you the last 64 bit will be make using NIC MAC address 48 bits, and they insert 16-bit value triple FE in the between MAC address. This is the process of EUI64 or extended unique identifier. Another option is router advertisement message, that is RA message. IPv6 router sets this message on link host periodically or in response to an RS request from another host. Router solicitation message. Hosts send this message to discover the presence and properties of on-link routers. That means they are discovering connected links. Basically, they are discovering connected links. With the connected links, they discover basically neighbor router or neighbor devices. It can be host, it can be another network devices. They are using two type of messages. One type is router advertisement message, and another one is router solicitation message. Router message or router advertisements message send or coming from router, and router solicitation message is coming from host or sending from host. That is the difference between RA and RS. Okay, that means reply and response. Okay, and last one is prefix list. When entries are present in the list, the router includes the entries in RA that the router sends to on link host. That is the final confirmation message of auto configuration. Neighbor discovery. Neighbor discovery. How to discover neighbor? The processor tracking. Neighbor discovery in IPv4. ARP is responsible. ARP is responsible, ICMP also responsible, or another protocol dedicatedly used to discover neighbor like CDP or LLDP. But in IPv6, an IPv6 router with ND enable, neighbor discovery enable, can send and information to downstream nodes. So if you enable ND or network discovery in your device, they will send the neighbor ND information to downstream devices. So when there is a recent information that neighbor received and processed IP traffic or neighbor solicitation request, one is neighbor solicitation request. And where there is no recent confirmation that the neighbor received a processed IP traffic or neighbor solicitation request, that means if you disable ND, that will not send any neighbor solicitation request. Or so if you enable ND, that will be sent neighbor solicitation message to downstream router. So the process of address auto configuration, basically when you configure or address auto configuration in a specific interface in your router, and there is two messages will communicate. One is router solicitation message and route advertisement. Router send the array and host send the arrays for confirmation. Okay, basically in address auto configuration, firstly link local address is introduced in interface by default. So first option, take from link local address first 64-bit. This 64-bit is taken from link local portion, and another 64-bit is coming from interface NIC card, 48-bit MAC address, and 16-bit value inter-between MAC address, that is the triple AV. If you configure a global or public IP address in your interface, this address is fixed and last 64 is coming through EY64. Okay, so this is the process when you configure auto configuration, your address will be like this. If you set public address and set EY64 for last 64-bit, you will get this type of addresses. Okay, and if you just enable the IPv6 and set the auto configuration command, and this interface will automatically making 180-bit IPv6 address. First portion is link local and second portion will be coming through EY64. So that is the method to make IPv6 address through address auto configuration. And second is stateful auto configuration. IPv6 also permits the DHCP address assignment, that is called stateful DHCP-v6. Like IPv4, IPv6 also provide automatic IP configuration through DHCP. So this is the stateful auto configuration through DHCP. The specific IPv6 address scheme you have to define. You have to define a DNS server address, and those the DHCP server will deliver the IPv6 address, including DNS servers and those IPv6 address gateway like IPv4. And see the interface configuration example, how to configure IPv6 in Juniper devices. Say here, two router is connected with each other, and one subnet is here. If we say 0:00:2:003 double colon 64, address double colon 1 is here, double colon 1 is here, and double colon 2 is here. So see the configuration of router 1. This is the router 1 and J0/0/1 unit 0 and family inet 6. For IPv4 we use inet, but for IPv6 we use here inet 6. Inet 6, then you have to assign the address. This is the difference. Inet 6 and here IPv6 address. That is the difference between IPv4. Okay, so this is the way to configure IPv6 address in a specific Juniper interface. Okay, how to verify the IPv6 address in interface? Just press the command show interface stars and mention the interface name here. Mention the interface name here. So first see here, first one is link local address. So why this is link local? See here, starting is FE80. If any address, any IPv6 address starting with FE80, that will be link local address. And FEC0, that is another manually configured address in that interface. How to check the routing table of IPv6? When you configure IPv6 address in your router, IPv6 table will automatically generate, and the IPv6 table will be inet6.0. If you want to see the IPv6 table, just press the command show route table inet6 or inet6.0. So this is the verification command to check IPv6 route. And if you enable the ND, so you can see the you can write this command show IPv6 neighbors that will uh, show you the neighbor addresses, neighbor devices information. First one, press the command show IPv6 neighbor. No entries here, just sending one packet to neighbor. Then see this command, and here number of entries coming here. It's a depend on uh, how many devices connected with this router. So IPv6 multicast address, like IPv4, IPv6 have multicast address, and multicast address range is double F double zero double colon slash 8. That is used for multicast in IPv6. Okay. Identifier for a set of interface that typically belongs to different nodes. All members of the multicast will process an incoming multicast packet, more efficient than broadcast. Obviously more efficient than broadcast. Multicast packets are processed only by nodes of the multicast group. Multicast packet can be forwarded over routers. ISMPv6 is used for multicast group management to optimize multicast traffic. So this is the multicast behavior in IPv6. IPv6 multicast address. Multicast address are identified the high order byte double F, starting with double F. If any IPv6 address is starting with double F, that will be multicast. Okay. So in multicast, the type of message will be RA, RS, and NS. That means solicited node multicast address. All node multicast address use RMSs. All router multicast address message is RS, router solicitation message. And the last IPv6 type is Anycast or Anycast addresses. It basically the concept of distributed cloud services. You can use same subnet in different location, and you will get a packet from nearest location. This is the concept of Anycast addresses basically. And next section we'll discuss the routing protocol, how to configure routing protocol in IPv6. First one, show you the static route configuration example. See here, this is router 1, this is the router 2. Router 2 is connected with the internet. So you need to configure default route in router 1 and router 2. So this is one example how to make the default route, how to make the IPv6 default static route. Just set routing options, RIP inet 6.0. This is the IPv6 route table, static route. Then mention the static route here. 0::/0. You can omit this 0::/0. That will be enough. Next hop and set the next hop IP address, and you can set here the preference. Default preference for Juniper static default preference is 5. Okay, you can set different preference if you want. So how to verify static route? Just press this command, show route table, inet 6.0 protocol is static. That will show you only static route from your router route table. Another routing protocol configuration example here, that is OSPF version 3, that is for IPv6. See here, two router is connected with each other, and first one, see the configuration of router 1 here. First one, set the router ID. Router ID will be IPv4 IP address, that is 32-bit. And add the interface which is connected with another router. This interface is connected with another router. This interface just go to WSPF section and add this interface under the area. Area can be 0 or another area. Basically, that's depend on your topology. Okay, and there is only two router, and both router is in backbone area or area 0. That's why here configure the area 0 and add the interface. Similarly, in router 2, first set the router ID and add the connected interface in WSPF. So that is the sample configuration of WSPF version 3. How to monitor or how to verify WSPF version 3? For WSPF version 3, just mention here WSPF 3. Similar. Just set here WSPF 3. Here is for version 2, use your WSPF, and version 3, use your WSPF 3. WSPF 3, WSPF 3. WSPF 3 neighbor, WSPF 3 interface, WSPF 3 database, WSPF 3 route. So see the command WSPF 3 neighbor, and here neighbor is neighbor address is, see here, neighbor state is full and neighbor address is here link local address. But in IPv4 there will be unicast address, but in IPv6 that means for WSPF version 3, neighbor will be link local address. All time neighbor will be link local address. And this is the sample configuration of ISS for IPv6. Basically, ISS configuration is identical for IPv4 and IPv6. There is no difference. There is no difference regarding configuration for IPv4 and IPv6. ISS have configuration for both IPv4 and IPv6. Okay. So if you enable ISS, just set family. You have to set the family. Family will be ISO. Family will be ISO. And you have to set ISO address. You have to set ISO address. This is the multiple section here. This is the INET number. This is the area code and the system ID. This option is the system ID and the subsection field. This is the format to define the ISO address of ISIS, and family INET 6. This is the loopback interface address, but ISO address is this one. Okay, and ISO address will be unique for unique for one router. If you use ISO value this one for router one, and this one not will be used for another router. Okay, so next, but go to the ISS protocol. Under the ISS protocol, just include your connected interface here. Include your connected interface here, which will be participated in ISS protocol. Just include those interface. So this is the sample configuration of ISS for basically IPv6, and this is the verification command. ISS is up or not. Okay, show ISS interface, ISS adjacency, and ISS adjacency detail. And the sample configuration of BGP for IPv6. For BGP, first option is same. You have to set the autonomous system number. You have to set the router ID under routing options, and under protocol BGP, you have to define the neighbor address. You have to define the neighbor address and local address if is in IBGP like IPv4. If is ABGP, that means a type is external, and you can define only neighbor address. No need to define local address. Local address is optional for ABGP, and you have to define the PRS also. This is the sample configuration of BGP for IPv6. And in BGP, IPv4 and IPv6 configuration is different, but configuration is identical but different. And this is the verification command of BGP. Just show BGP summary, and you see here the status established and the time from 4 minutes. BGP has established. So next section is tunneling IPv6 over IPv4. Tunneling IPv6. You can send IPv6 packet through IPv4 tunnel. So there is one example here, tunneling IPv6 traffic over IPv4 networks. See here, encapsulate the native IPv6 packet inside IPv4, forwards the IPv4 packet through IPv4 network. That is possible. De-encapsulate the IPv6 packet and forwards process natively. That is the tunneling IPv6 traffic over IPv4 networks. This is the way out. 6 to 4 or 6 over 4. So here is one example here. See here, site A, this is IPv6 address. Site B, this is IPv6 address. But in internet, there is IPv4. In internet, there is IPv4. See here, tunnel interface. So 0/0/0 unit 0 tunnel. This is the tunnel interface. You mention here IPv4 source address. This one is the IPv4 source address. This one is router 1. So and destination address this. When you make a GRE tunnel, you have to mention source address and destination address. So you mention here source and destination address. Similarly, in router 2, you mention here source and destination address. After setting source and destination address in GRA tunnel interface will be up, and set here IPv6 address. Set here INET6 IPv6 address, just point to point to make the tunnel. So when user A send IPv6 packet to user B, this packet is coming in router 1 and just going to tunnel interface to another endpoint router and deliver to another site B or another user. That is, the mechanism is IPv6 packet is encapsulated in IPv4, then de-encapsulate here and de-encapsulate to IPv6 here and send the packet to user B as a IPv6. So this is the tunnel process possible in IPv6. And you, when you want to get access from user A and user B, that is different router and different network, you have to make IPv6 route here. Okay. Okay. This is the process to get reachability of different network. And this is the verification command on GRE interface. And finally, the route table, IPv4 and v6. And sending ISMP request from one source to destination. Okay. And lastly, checking the traffic statistics. So basically that's all for IPv6. And then now I will go lab section. Okay. Now I will go in lab section. So in our lab section, first one is I have to configure IPv6 address and verify is it working or not. First lab will be testing IPv6 address. So when IPv6 auto configuration, yes, this slide number 34, interface configuration example. So take here two routers, take here two Juniper routers, node, BMX. Number of router is I take here three BMX, that is Juniper router I mentioned here, and number of interface is 8. There we are. This router for checking IPv6. Okay, so this router set name here ISP, internet service provider, and I use here cloud PNG. That's okay. This is router 2 and this is router 1. Okay, connecting service provider G0 by 0, 0. That's okay. And connecting 0, 1 and 0, 1. Yes. So choose here IPv6 address. So 2024 colon and FSCE double colon. That is point to point. I can set here 1. Okay, colon double colon slash 64. I can use slash 127 for point to point, but I use here 64. Okay, so 11 slash 64 and duplicate. This is for point to point, or we can use basically 126. No need to use. Also, we can use 127. Okay, but choose here 126. So first one is double colon 1 slash 128, and that is used for loopback. That is used for loopback here, and that is 12024 FSC double colon 128. This is our first router, and second router. Second router loopback is 2. Second router loopback is 2. And here IP address is duplicate. Consider here FSC. I choose here A, B, C, D. 11 slash 126. And another loopback address is here. Another loopback address is here for testing. Hello 0 dash, and I use here double colon 1 slash 128. That is our address plan. And so first start this one. Mhm. Mhm. Enter 1, router 2, and the router 3. So wait for some time. We can pause. Login, root. Password is root 123. Some credential here. Root. Root. SP, ISP, root. Display set. Just remove basic configuration from, just remove default configuration first. Logical router. No need this one. The management interface should be delete, and the router name will be Juniper 1. That's okay. Same thing will be this router, router 2, 2, children, and this is ISP. ISP router. Commit. Yeah. Okay. First, configure IPv6 address and check it's working or not. So, router 1, there is two interface here. One is loopback interface, another one is G0x0x1. So set interface hello0 unit 0 family here inet6 IPv6 protocol parameters. So inet6 address, then you set here IPv6 address. So our example address is 2024 colon FSCE colon double colon 1/128. Set interface GE dash 0x0x1 dash 0x0x1 unit 0 family inet 6 address is 2024 FSC colon 1111 double colon. I use here 1/126. Okay, commit. So our configuration is should display set loopback interface. The IP address is 1. In router 2, IP address is 2. In router 1, interface 1 address is 1. In router 2, address is 2. Okay. Interface loopback. Another interface is connected with ISP. And the ISP interface is set interface GE dash 0x0x0 unit 0 family inet 6 address, and address is 2024 colon ABCD colon 41 double colon I use here 2/126. So that is address configuration done. Final in ISP set interface hello0 unit 0 family inet 6 address. I configure address is 2024 colon ABCD double colon 1 slash the value prefix length is 128. And another interface is set interface ZE dash 0 by 0 by 0 unit 0 family inet 6 address. Another address will be mm, this one, and address will be 1. Yes, my address configuration done. How to check this one? Show interface and press your interface name. Interface starts, press your interface name. Say here, this interface IPv6 address is this one. This one address is manually configured and other address is automatically configured here. This is called the auto configuration, address auto configuration. First one is link local portion and last one 64-bit is coming from UI64 method. Okay. This is the configuration sample. See here the status. Okay. Now see the route table and see the ISMP packet is communicating or not. Okay. So first run show route table. See here inet 6.0. So set inet 6.0. This inet 6.0 table, that is IPv6 route table, is here. All address here IPv6 address. Okay, checking done. Then checking the ISMP and IPv6 neighbor. So from router 1, just from router 1, Z0 by 0, 1, one interface is connected with this other. You can send ICMP request to your neighbor router. This is itself and this is neighbor router. So ICMP is communicating. Okay. And check here IPv6 neighbor. IPv6 neighbor has discovered or not. Run show IPv6 neighbor, or you can route our advertisement command also here. Yes, IPv6 neighbor is coming here, and this is the IPv6 address. Okay, and this is the link local address, link layer address, not the link local, and state is breathable. Okay, and the interface is this one. So our checking done, they are communicating with each other and making V6 neighbors. Okay. So next configuration section is routing protocol. First one is static route. First one is static route. First one is IPv6 default static route. Yes, default static route. Second one is OSPF. So first one is IPv6 static route. So see here our topology, and this is IPv6 loopback. This is connected with ISP router. So if I want to send packet from router 1, consider this is your source IP and this is your destination IP. If you want to send from this source any packet towards the destination and need routing protocol. So if I make here default route, from router 2 to ISP and router 1 to router 2. And if I make a specific route from ISP to router 2 and router 2 to router 1, that will communicate. So let's configure static route. First one is default static. So first one is default static. So my neighbor is 2. My neighbor is 2. So how to set the IPv6 default route? So set first routing options, RIB, RIB, routing information base, RIB, and set here IPv6 route table, IPv6 route table, this one. Then static route, and set here is static route /0. This is IPv6 default, IPv6 default. Then you have to set the next hop. My next hop will be one, that is router 2, no, that is 2, that means this is the second one, z0 by 0 by 1. So set the next hop, and you can set here other other static route parameter. You can set your preference and other options. Okay, so no, this is optional. No need to set this optional value right now. So come this one. Say run show route table name is inet 6.0, and you want to see only static route. Then set your protocol, and you can mention here is static. You can mention here is static. So this is your static route. Okay, static, and the default preference is 5, and this is your next hop, and this is the exit interface. So same thing will be a repeat in router 2. So use configure default route from router 1 to router 2. Again, you have to set default route router 2 to ISP. So set the default route. Show display set. So default route will be show display set. Default route command is like this. Okay, only next hop will be changed. For router 2, next hop will be this one. Next hop will be this one. Okay, then commit from ISP. I set here a specific route. I set here a specific route. Like I set here not default route will be this 2024 colon FSC 2024 colon FSCE //32. I mention here is specific route from ISP. Next hop, my next hop will be 2. My next hop will be 2. So this is the return packet ISP to router 2, and router 2 will mention a static route to reach this destination. So for router 2, we can set here 2024 colon FSC :1/128. This is a specific route, and The next hop will be next hop will be 11. This is 11 FAC 11 double colon. This is 2. So next hop will be 1. Yes. Now try to send packet from router 1 to ISP loopback. So run ping. Yes. So you can mention here source. Source will be router loopback. Yes, it's working. Or you can check the path trace route. Yes. First one is double colon 2. That means router 2. And finally, ISP loopback interface. So this is the checking of static route, specific static route, IPv6 default static route, and ICMP. So next, move on to OSPF. Next, move on to OSPF. OSPF version 3. For OSPF version 3, we need 32-bit router ID. 32-bit router ID. In that case, we can choose here. In that case, you can choose here IPv4 loopback. IPv4 loopback like 192.168.1.1. 1.1/32. That is enough. And this loopback will be 192.168.1.2/32 single IP. That is enough. Okay. So I cite here set interface hello0 init0 family init address 192.168.1.1/32. That is loopback interface address, IPv4 address, that is 1.2, that is IPv4 address for router 2. Okay, so configure WSPF version 3 interpreting router 1 and router 2. Router 1 and router 2. Okay, let's start. Remove static route from here. Edit routing options. Remove this one. No need static route. Now we are going to dynamic routing protocol. That is static commit. And in router 2, edit routing options. Show display set relative. This default route is towards the ISP. That is needed also. No need this route. No need this route. But we need default route here. Okay. To reach ISP router. So first set, or you can edit protocol OSPF and OSPF version 3. Set area, choose here area 0 and set the interface here. Interface hello0.0 and interface is passive, and another interface is GE dash 0/0/1, and the interface type will be P2P. So display set. This is two-line configuration, and where we set the router ID, set routing options router ID. The router 1 router ID will be the loopback address loopback IPv4 address. This is router ID for router 1, and this is router ID for router 2. Yes. Loopback 0 is under area, and this one interface and area will be 0, and interface type will be P2P. That's okay for WSPF. Run show WSPF 3 neighbor. Yes, WSPF 3 neighbor is off, and the neighbor is link local address. So run show route protocol WSPF. Yes, getting one route from WSPF 3, and the preference default preference is 10. That means I'm in router 1, I'm getting loopback IP of router 2 through WSPF routing protocol. Okay, so I need default route in router 1. So in that case, we need a policy. Any policy option policy statement default D FAULT default ROUTE V4. So set 100 from route filter double colon /0 double colon /0 exact 100, then accept set from 1000, then reset. So you are just accepting only IPv6 default route under policy, and edit protocol WSPF, sorry, WSPF 3, set protocol WSPF 3, export the policy default route. So I'm exporting default route in WSPF domain. Router 2 will advertise default route to router 1 from WSPF. So check here. Yes, getting default route, and default route is redistributed route 150, and that is coming through WSPF 3. Okay. Again, check the connectivity. So taking loopback interface from ISP and send packet from router 1, run ping loopback. Yes, it's working. And you can also set your source address, your loopback address. Okay, no issue. That also working. So that is the example configuration of WSPF version 3. And this is the basically verification. So WSPF 3 neighbor, WSPF 3 interface, database, route. Okay. So cite here the command, neighbor, yes, neighbor, and you will get other option here. Okay. You can set route. This is default route, and default route is external route. Okay. Default route is your external route. See here, IPv4 prefix also here. Okay. Then interface, which interface is participating in OSPF? G0 by 0 by 1 and loopback 0. And you can check here also database OSPF 3, OSPF 0, OSPF 3, link local database. So our checking done, OSPF checking done, then go to ISIS. How to check the ISIS configuration? So first, you can remove OSPF configuration So how to remove this one? Delete, or you can keep this configuration, no issue. Just for ISS configuration, you have to enable family ISO. You have to enable family ISO, first one. Second one is you have to set the ISO address. Normally we use ISO address taking from loopback address, loopback IPv4 address. And under ISS protocol, you have to include participating interface. That is the step. Okay. So first one, in router one, set interface LO0, unit 0, family, unit 0, family. Family should be ISO. OSI ISO protocol parameter. Okay. Another interface is 001. G is 001 and unit 0 family ISO is the first option. ISO. And after ISO, you have to set the address. You have to set address here. Like example address configured here area 2 and router 1 is all 1. I can also set same thing. That will be under loopback 0. That means LO0, unit 0, family ISO address. Family ISO address. And set the address here. I copy this address 49.002. 2 means area 000 to 49.002 and colon total 3 section 1 2 3 3 section colon 00. This is ISO address. So show display set commit. First one, the loopback interface, family ISO area, and this address. Go to router 2 and I set here different 222. ISO and ISO address define done, and I have to define family ISO in interface 001. That is done. And final set protocol ISIS, set protocol ISIS, and the interface. Interface is LO0. Another interface is G0/0/1. So same thing will be in router 2. Same thing will be in router 2. Okay. So our configuration done. Configuration done. So configuration done, then check verification, ISS verification. Okay. So for ISS verification, show ISS interface, show ISS adjacency and adjacency detail. Run show ISIS and you will get others command here. First one is adjacency. See here, interface. This is ISS level 1 and level 2. They are making neighbor. Okay, and neighbor is up. Another is ISS interface, which interface is participating. 1 and loopback 0 is participating. 0 is passive, and another interface is P2P. Default metric is 10, and this is for level 1 and level 2. And adjacency detail, you can take adjacency detail. This is for status up, this is for level 1, and this information is for level 2. Level 1 and level 2 router. Okay. And see here, IPv6 address and IPv4 address. Both address speaks IPv4 and IPv6 both. So this configuration for IPv4 and IPv6 both protocol configuration is identical in ISIS. Okay, so let's move to BGP. How to configure BGP? So see here, your multiple router is here. So set 1S for BGP. So set here S number is like 100 or like 777. I set here is 777 duplicate, and I use here set S number 174. Okay. So this will be IBGP. Router 1 and router 2 will make IBGP session, and router 2 and ISP will make EBGP session. Okay, EBGP session. So in that case, how to make this one? Firstly, we have to mention the routing options autonomous system. We have to mention the autonomous routing options. AUT autonomous system is 777. Okay, number 1 done. Set routing options autonomous system. Router 2 autonomous system is router 2777, and ISP router autonomous system is 174. Done. Autonomous system configuration done. Then need to apply the router ID here. So I take here another IP 10.1.1.1/32 IPv4 set family set interface L0 unit 0 family inet address is 10.1.1.1/32. So set routing options router ID. Router ID will be loopback address 10.1. Okay, commit. So starting BGP configuration. So set edit protocol BGP group IBGP basics. Set type will be internal, that is IBGP, right? Set local address, and the local address will be loopback address, loopback IPv6 address. Local address will be this one, and the neighbor address will be neighbor will be a remote loopback 2, that is 2. Okay, and PRAS will be 777. Okay, and need a policy, next of cell policy. So set here next of cell policy. So I copy next of cell policy from another section. Wait for a minute.